All right, hello 20-1 students. So today we're looking at the second part of our radical equations lesson, 5.3. So we're just going to work with a few more problems where we're working to solve, basically solve radical equations, okay? So the first one we're going to look at here is we have 7 plus root 3x is equal to 5x plus 4, all under a radical plus 5. So the first thing we want to do is isolate one of the radicals. And so basically what we can do there is, because each one of these has like a radical plus something else, like just plus a number term, we want to move one of those number terms over. So for this one, I'm going to move, usually you want to try and isolate the more complex radical. So 5x plus 4 is more complex than 3x, so I'm going to isolate that one by subtracting 5 from both sides. So I'm just going to jump right into this one here. So 7 minus 5 gives me 2 plus 3x, root 3x actually, is equal to root 5x plus 4. Okay, so the 5 is subtracted off there, so we're left with this. Now the next thing we want to do is try and start working towards eliminating some of the radicals so that we can solve for our variable. So the isolated radical is the one that if we square it, we'll remove that square root, and then we'll just have this set of terms with the other side here, because we're squaring it and there's two separate values, it's not going to work out quite that nicely. So we'll deal with that in a later step. So the next step here is square both sides. So I'm going to square this and I'm going to square that. So when I square this, I'm just going to have the two brackets multiplied by each other, right? 2 plus root 3x multiplied by 2 plus root 3x. And then squaring this side, because everything on this side is under the radical, it's just going to eliminate that radical. So we're going to be left with 5x plus 4 on that side. Now what we want to do is go through and simplify the squared side. So first we want to multiply it all out and then simplify it down. So 2 times 2 is 4. 2 times by 3x, or sorry, first outside, so 2 times by 3x, or root 3x, sorry, is 2 root 3x. And then inside, so again, 2 times by root 3x, both positive, so plus 2 root 3x. And then the last two, if you multiply these two radicals together, that's the same as squaring them. So basically you're eliminating the root and you're just left with plus 3x there. Okay, and so that's equal to 5x plus 4. Nothing changes on the other side. And then work to simplify this a little bit. So basically that means combine like terms. So 2 root 3x plus 2 root 3x is 4 root 3x. 4 and 3x we can't combine because they're not like terms. So we have 4 plus 4 root 3x plus 3x equals 5x plus 4. Now what we want to start doing is these two are like terms and these two are like terms. So we want to isolate this radical again by moving these terms over to this side. And because they have like terms on the other side, we can do that. So positive 4, we want to minus 4 off. Plus 3x, we want to minus 3x. And then the same thing on the other side. So plus 4 minus 4, 5x minus 3x. And when we do that, we end up with 4 root 3x. And then obviously these have canceled out. So 5x minus 3x is 2x. 4 minus 4 is 0. Okay, so now we have simplified it down quite a bit, and basically what we want to do now is try to solve for x. So the first thing we're going to do, again working to isolate this radical, we can do that by dividing 4 away, right? And if we do that to one side, we have to do it to the other side. So 4 divided by 4 leaves us with root 3x 2 divided by 4 leaves us with 1/2 x. Okay, now again, we have simplified down to the point where we just have a radical. How can we get rid of the radical? We can do that by squaring it because it's a square root. So we're going to square both sides. So when we square this side, we're left with 3x. When we square this, 1/2 squared is 1/4 x squared. And now we want to try and eliminate let's see, the quarter from the x squared value. So we can do that by dividing it out. And just keep in mind that dividing by a fraction is the same as multiplying by the reciprocal. So 3 divided by 1/4 is the same as 3 times by 4/1, which is 4. So we end up with 12x is equal to, quarter divided by 1/4 cancels out, and we're left with x squared there. So 12x equals x squared. Now the last thing we want to do is try and set this expression equal to 0. So basically we want both of our terms on the same side now that we've simplified them as much as possible. The main thing to keep in mind, because you might be wondering like, well, why aren't we trying to divide away the 12? But keep in mind we're trying to make sure that our x squared term doesn't have a number value in front of it. And we can't really divide out 12x out of both sides because all that would do is leave us with 1/12 on this side. So we're simplified as much as we can be here. Oops. And so now we just want to set the expression equal to 0. So basically that means we're going to subtract 12x from this side, just because I find it personally easier to keep your x squared value positive. So if we subtract 12x from each side, we end up with 0 is equal to x squared minus 12x. Now the last step we can do is see if there's anything that we can factor out of this expression to make it even simpler. So what we can do is x is the common term to each, or the common factor, I guess, for each of these. So it'd be 0 is equal to, if we factor x out of here, it'd be x times by x will give us x squared, minus x times by 12 will give us 12x. So now we have this really nice simple factored form which helps us to solve for what the possible values of x are, because we know that this expression has to be equal to 0. In order for that to happen, either this whole bracket would need to be multiplied by 0, so x would have to be 0, or the x on the inside would have to add up to 0, so the outside one is multiplied by 0. So the only thing that will do that is if we have positive 12 here, minus 12 would give us 0. So x could also equal positive 12. So these are our two possible values for x. Now we want to do verifications to see if one or both of those are correct. So we can try that out for 0 first. If x is equal to 0, basically what you want to do is go back to the beginning and fill in 0 for your x values and see if the statement is true. So 7 plus root 3 times by x, which we said would be 0 here, is equal to root 5x, so 5 times by 0, plus 4, plus 5 outside the radical. Okay, so that ends up being 7 plus 3 times by root 0 is 0, root of 0 is 0. I'll put it in there though, plus root 0 is equal to 5 times 0 is 0 plus 4. So basically we just have root 4 plus 5. 7 plus 0 is 7. And that is equal to root 4 is 2 plus 5, which is 7. So we can say that we've verified that x being equal to 0 does work for this formula. Then the next thing we wanted to verify was 12. So again, just fill it in. 7 plus root 3 times by 12 is equal to 5 times by 12 plus 4, all under the radical, plus 5. So 3 times 12 is 36. So 7 plus root 36 is equal to 5 times 12 is 60 plus 4 is 64 plus 5. So 7 plus root 36 is 6. So 7 plus 6 is 13. And root 64 is 8 plus 5, which is 13. So that is again correct. So x can be equal to 0 or 12 for this formula. Okay. All right, let's try one more question like this. Little bit more complex, this one. So solve for 3 plus x plus 2x minus 1 being equal to 5. Okay, so let's go through this one. First of all, we're going to isolate one of the radicals again. So in this particular case, we don't specifically have a more complex radical than another. They both have like a term, like a number term, and then a term that includes the variable. So let's maybe look at just getting rid of, we'll keep this first one, and then because it's plus this, we'll just subtract that off the other side. So basically we have root 3 plus x. We want to move this 2x minus 1 over to the other side, which is already has a 5 there. So basically we're doing minus root 2x minus 1 from both sides. I'm not going to write it out again. You guys know what I'm doing. So basically we end up with root 3 plus x is equal to, because root 2x minus 1 minus root 2x minus 1 is 0. So then we have 5 minus root 2x minus 1. Okay, now just like last time, we want to start whichever side we have an isolated radical on, we want to try and start simplifying that, and the first thing to do is to square it to get rid of that radical sign. So let's square both sides here. And so again, that's going to just leave us with 3 plus x on this side, which is nice. But on the other side, we're going to just have these two brackets being multiplied by each other, right? So 5 minus root 2x minus 1 times by 5 minus root 2x minus 1. Okay, now we're going to have to go through and multiply that out. So again, 3 plus x is going to be equal to 5 times 5 is 25. First outside, so minus 5, because we have a negative here, so minus 5 times by 2x minus 1. And then inside, again, 5 times by negative 2x minus 1 is minus 5 root 2x minus 1. And then last, so negative times by negative is a positive, and because we're basically squaring this, we remove the radical and we're left with 2x plus 2x minus 1, right? So basically you're saying like negative times by a negative is positive, so you're saying plus this expression, but because 2x was positive in this expression, it stays positive, but then negative 1 still stays as negative. So basically everything stays the same as it was under the radical because you're adding them. Let's see. Now what we can start to do is look at simplifying. So like for example, here we have 25, which is just a number value, and here we have minus 1. So we're going to have 3 plus x is 25 minus 1 is 24. Negative 5 minus 5, we're going to do minus 10 root 2x minus 1. Okay, so just combining the two like terms, and then plus 2x. Now again, what we want to do is start working to isolate that radical again. So new sets of steps. We want to move the 2x away, so minus 2x. And we want to move the 24 away, so minus 24, which is going to happen to this side. So x is going to be minus 2x, and 3 is going to be minus 24. So 3 minus 24 gives us negative 21, and then x minus 2x gives us negative 1x, so negative 21 minus x is equal to, on this side we're just left with negative 10 root 2x minus 1. Okay, so now again we still have one more radical. We want to try and isolate that, so same set of steps as we started through up here, right? We're just going through and basically repeating. We want to square both sides. So square that. Now that means we're going to have negative 21 minus x times by negative 21 minus x. And then on this side, negative 10 squared is going to be 100. And the radical squared is just going to be what's inside of it, so 2x minus 1. So it's going to be 100 multiplied by what was under the radical there. So now we can start simplifying. We're going to multiply through our brackets in this step. So negative 21 times by negative 21 is positive 441. Negative 21 times by negative x is positive 21x. And then same thing here, plus 21x. And then negative x times negative x is positive x squared. 100 times by 2x is 200x. And 100 times by negative 1 is negative 100. Okay, so let's look at combining like terms here. So this is going to be, let's see, 441. I guess I'll just simplify it in one step here. So 21x plus 21x is 42x plus x squared equals 200x minus 100. Okay, and then let's try and move. So we have a value with the x variable, and we have just a number term. So we can move both those to the other side, and in that step, that means we'll be setting everything equal to 0. So we're both simplifying and setting it equal to 0 in this step. So minus 200x and plus 100. So on this side, plus 100 will go here. Minus 200x will go here. And we can sum that up. So 441 plus 100 is 541. Positive 42 minus 200 would be minus 158x plus x squared. And then these two have both canceled out here to leave us with 0. So now we're left with this kind of somewhat complex set of values here. And so the easiest way to probably work with this would just be to use the quadratic formula. So it's not written in the proper order, but our a value goes with x squared, so a is equal to 1 for this one. B goes with x, so it's negative 158. And c is our last term there, which is 541. So now we can put that into our quadratic formula. So we have negative b, so negative 158, so that's basically positive 158, times by this, or sorry, plus or minus the square root of b squared, so negative 158 squared, minus 4 times by a, which is 1, times by c, which is 541, and then divide it all by 2 times by a, which is 1. Simplify that out really quickly, so we're going to have positive 158 plus or minus the square root of, when you do the math for all of that, you should get 22,800 square root divided by 2. Now we just want to factor out as much as we can here. So we're going to have 158 plus or minus. Can we factor this down at all? So what I would say here, usually whenever you see like multiple zeros there, my first step would be to divide by 100, because we know that 100 is a squared value, so it can be easy to factor something out of there. So if you go into your calculator and you do 22,800 and you divide it by 100, which is 10 squared, you're going to be left with 228. 228, same thing. You would basically want to think about what squared values you might be able to factor out of there. So seeing that it's an even number, I'm going to try 228 divided by 2, which gives me 114. So I'm going to try 4, which will be a squared value, divided by 4, 57. So that's an even number. So we could do 4 times by 57 gives us 228, and 4 is 2 squared. 57 we can't factor down anymore, so we have 2 squared values we can pull out of there. So basically the 10 and the 2, and when we multiply that together, that's going to be 20. So we're going to have 158 plus or minus 10 times 2, which is 20, times by root 57 will be our remaining value here that we couldn't factor any further. And then all of that is over 2. Okay, so now we have our quadratic expression. If we divide this by 2, 158 will divide to make 79. 20 will divide by 2 to make 10, so 79 plus or minus 10 root 57. There's our simplified expression that we can use for our final exact value. Keep in mind that if you're on a test, if it asks you for exact values, you have to leave it in this form. Don't bring it to a decimal point. However, in order to do our verification, it is helpful to bring it down to a decimal point. So basically, you would do 79 plus for our verification, 79 plus 10 root 57, which gives you 154.5 something, so that's our decimal. And now we want to run through a verification for that. So we go back to our original expression here, root 3 plus 154.5 plus root 2 times by 154.5 minus 1 should be equal to 5. So 3 plus 154.5. Remember to use the full decimal always for your calculations, plus root 2 times by 154.5 minus 1. Whoops. Not equals. Sorry guys, I lost my 2 times by 154 minus 1 is equal to 5. Okay. So let's see, what does that give us? Root of this gives us 12.54 something plus root of this gives us 17.54 something. And so you can see 12 plus 17 is obviously not going to be equal to 5. And so the 79 plus 10 root 57 is not a valid expression for this equation. So let's try 79 minus 10 root 57. That gives us 3.5 something. So again, root 3 plus 3.5 plus root 2 times by 3.5 minus 1 equals 5. So 3 plus 3.5 gives us, and then square rooted gives us 2.45 plus 2 times by 3.5 minus 1 gives us 2.54. Again, extended decimal. And if you put that in, if you've used all of your decimals properly, you should get 5 as your answer. So that is correct. So after our verification step, we can say that even though we came up with this full expression, the correct final one is 79 minus 10 root 57. Okay, so just in a test, make sure that you would verify and conclude which one of these is the correct version in order to get full marks. And also just keep in mind that you should show all of your work in a test in order to get the maximum amount of full marks. Okay, so if I haven't seen you working through some of this stuff you could you could squinch together a little bit more, right? Like I don't need to see every single step, but I should see the basic steps written out in a test for you to get full marks. Okay, so you have some practice questions to do there, and then you're finished the chapter, so you can go ahead and get studied up for the test and write that whenever you're ready. So happy studying.